Hi everyone. So today I'd like to share with you one of my favorite little tricks in math. This is just a trick to help you find the horizontal asymptotes of a rational function. So what do I mean by rational function? I mean functions that look like this, where you have one polynomial divided by another. So let's see how this works. So first thing you're going to do is determine the degree, which is the highest exponent. We're going to determine the degree of the top and the bottom. And then we're going to use this little rhyme, or whatever you want to call it. Bob yo, bot no, eats DC. So I'll explain what each of these three mean. Bob yo, start with that. Bob yo means bigger on bottom, y equals 0. And that means if the degree is bigger on the bottom, then the horizontal asymptote is y equals 0. And we'll look at these examples in a second. I just want to go through what the rules are right now. The second thing we have here is bot no. If the degree is bigger on top, then there is no horizontal asymptote. And finally, we have eats DC, and that means if the exponents are the same, then we divide the coefficients of the leading term. So let's have a look at how this works. So here we're asked to state the horizontal asymptote of these rational functions. And the first one we have here is y equals 2x plus 1 over x minus 2. So first thing we're going to do is determine the degree, the highest exponent of the top and the bottom. So on top, we have a linear function, 2x plus 1. The degree is 1. The highest exponent on x is 1. And on the bottom, we have another linear function. The degree on the exponent on x is 1, so the degree is 1. So that means we're dealing with this situation. The exponents are the same, so we're going to divide the coefficients. And when I say divide the coefficients, I mean the coefficients of the leading terms. And the leading terms are just the terms with the highest exponent. So this is eats DC, and we're going to divide 2 by 1. Those are the coefficients of the leading terms, 2 and 1. So y equals 2 over 1, y equals 2. So our horizontal asymptote is y equals 2. And that just means that as the graph goes off the edge of the page, the graph will be approaching the line y equals 2. Let's look at the second one right here. F of x equals 1 over 3x plus 5. So we compare the degree of the top and the bottom here. We don't have any x terms on top, so that means the degree is 0 on top. And on the bottom here, we have a linear function, so the degree is 1, the highest exponent is 1, and that means we're dealing with this situation here, bigger on bottom. This is Bob yo. So we are bigger on bottom, and that means our horizontal asymptote is y equals 0. And that always happens when you have a constant divided by some polynomial in terms of x. You're always going to get y equals 0 as your horizontal asymptote. Let's have a look at C here. So this one's a little bit trickier. Our terms are not in the usual order that we see them. So we have 2x minus x squared plus 3 on top, and 3x squared plus 1 on the bottom. So which of the three situations is this? Well, our leading term on top is actually this one right here, negative x squared. And our leading term on the bottom is 3x squared. These are the two terms with the highest exponents, and they both have exponent 2. So we have degree 2 on top and bottom. This is eats DC. The exponents are the same on the top and the bottom, so we're going to divide the leading coefficients. And that's going to give us negative 1 on top. Coefficient on this term is negative 1. And 3 on the bottom. So we get a horizontal asymptote of y equals negative 1 over 3. And lastly, let's look at this final one right here. Y equals x squared plus 5x plus 6 over x plus 4. What is the degree of the top? The degree of the top is 2 because the highest exponent is 2, and the degree of the bottom is 1 because we have another linear function on the bottom. The highest exponent on the bottom is 1. So we have 2 on top, degree 2 on top, degree 1 on the bottom. We are dealing with this situation right here, bigger on top. So our degree is bigger on top by 1, and that means we have no horizontal asymptote. So we're dealing with bot no. So we have no horizontal asymptote in this case. Now, the degree of the top here is exactly one more than the degree of the bottom. That actually means that we have something called an oblique asymptote or a slant asymptote, but we're going to save that for another video. So I hope you found this helpful. Bob Yo Bot No Eats DC. That is my little trick for remembering how to find the horizontal asymptotes of a rational function. See you in the next video.